Thunderstorms are common, everyday occurrences. A few thunderstorms are able to reach the severe stage where they produce hail, lightning, heavy rains, and tornadoes. Thunderstorms which reach such a supercell stage develop a very organized internal structure. This allows them to survive for a few hours in a strong wind shear environment. In this illustration, winds are entering the storm just above the cloud base and are coming from an easterly direction. The warm air rises through the cloud and collides with winds coming from an opposite direction. This creates a double vortex inside the thunderstorm with cyclonic circulation in the southern half of the storm, where a large updraft exists. This updraft is embedded in surrounding horizontal air currents coming from different directions. These various opposing air currents and updrafts can be modeled in the laboratory by the proper arrangement of fans. The laboratory model is based on Doppler radar measurements from thunderstorms. It is created by producing an updraft with a fan mounted above a 9-foot ceiling. The 24-inch fan produces an updraft which simulates the updraft in the cyclonic region in the southern part of a thunderstorm. The updraft is created through a 20-inch circular opening in the ceiling. The horizontal air currents are modeled by two 12-inch fans, which create winds from different horizontal directions. Ordinary air is invisible unless it contains a visualization material. The ice fog created by dry ice is useful for this purpose. Thus, the laboratory model is a white vortex. Sometimes tornadoes are white because they're composed of condensed water vapor and are viewed against a dark background. Such a dark background is often provided by heavy rain. Other tornadoes pick up dust and debris from the ground and look very dark. When the updraft and horizontal air currents are generated by the fans, they combine and create a tornado-like vortex which extends from the ceiling down to the floor. As the vortex picks up the ice fog, we are able to see it. The vortex is composed of circulating air around an inner core. The laboratory tornado was developed by Dr. Eagleman and is not enclosed within a cage like most other laboratory models which have been produced in the past. It is, however, generated in a manner which is similar to the generation of tornadoes in the atmosphere. Doppler radar measurements of the winds in a severe thunderstorm show that an updraft exists. This updraft is surrounded by opposing horizontal air currents. Thus, the generation of the laboratory tornado is modeled from the air currents within a thunderstorm. Since accurate measurements are difficult or impossible to obtain within tornadoes, the laboratory model is useful for investigating the various characteristics which it may share with the tornado. Many of the aspects of tornadoes are not well known because of the difficulty of measurements. The laboratory tornado maintains a definite structure which includes low pressure in the core of the vortex. Air tries to enter this low-pressure region inside the vortex from the surrounding region. The surface horizontal inflow reaching the vortex comes from considerable distance outward from the center of the vortex. The vortex narrows down to a point as it extends down to the floor. The point is characterized by very strong horizontal winds around the center. The diameter of this point and the diameter of the core can be seen to change frequently. This point is similar to the touchdown point of a tornado. It can be seen that the air currents near the floor spiral around the core in an upward direction, similar to the winds in a tornado. One of the areas of great concern is the interaction of the tornado with the surface. Some related applications include the design of buildings to better withstand the winds within a tornado and better information on safety during severe weather. Even though the laboratory vortex is generated 9 feet above the surface, it interacts with it vigorously and can be seen in close-up views of the action at the base of the vortex. As a tornado develops at the ground and moves across the terrain, it gives very few clues as to its generation mechanism and sustaining air currents. Similarly, the study of the lower part of the laboratory vortex provides little information as to its cause. However, it is possible to study the generation mechanism of a laboratory vortex. We know that it's created by an updraft and opposing horizontal air currents.